Hey guys, going to go over the review here for your last assessment of calculus for the year. All right. Um, Now, notice how I have my formula sheet right here. All right. Very handy. I would make sure for your quiz, whether you're taking it Thursday for class 7 or Friday for class 1 or class 5, that you have this available during the quiz. Okay. Makes life so much easier just following like recipes. Okay. Um, the way the quiz will be set up, very similar to the way the review is set up, where one side would be derivatives, the other side will be integrals. Just won't be as many. Okay. But the types will come from types that are in here. Okay. Just make sure you take it during your assigned class period. All right. So let's get right to it. All right, so these are all derivatives, which means we're going to be all looking at the left side of the paper. Okay, so first one is arc cosine 3x. Well, what formula are we going to look at over here? We are going to look at inverse it's arc cosecant. Sorry, I couldn't read. It is this one right here. All right, so in this case, the u that they reference is the 3x. That's what comes after. All right, so it's negative du. So negative, what's the derivative of 3x? 3 over the absolute value of u, which is 3x, over the square root of u squared, which is 9x squared minus 1. These 3's would actually cancel, and this would be negative 1 over x times the square root of 9x squared minus 1. And there's your answer. All right. Now, if you left this as your answer, correct. That's fine. All right. You could cancel out the negative, the 3's, but like I said, if you just leave this, you're going to be good. All right. So here we have 2, so a constant raised to e to the x squared. There's a lot of stuff going on here. All right. But the first thing you have to look at is we have it's a to the u. This here we have a constant raised to an exponent. So we're going to do a to the u natural log of a du. All right. So I have a to the u, which means we rewrite the entire thing. So it's going to be, I'm going to switch colors just to not get confused. So it's going to be 2 e to the x squared times the natural log of a. Well, what's a? A is the base, which in this case is 2, times the derivative of u. Well, u is the exponent, which is e to the x squared. Well, how do I find e to the x squared? You do this formula, e to the u du. So this is times e to the x squared times the derivative of the exponent, which is x squared, which is 2x. And just leave it like that. Don't try to even combine anything. Just leave it like that, and I'm completely fine. All right. All right. See, we have a log, natural log, we have a sine, but what comes first? The sine comes first. So we have to look at the derivative of sine is cosine u du. All right. So it is cosine, keep the inside the same, which is natural log of the square root of x, times the derivative of the inside, which is a natural log. Well, how do I find derivative of natural log? It's right here, du over u. So the derivative of the square root of x, remember square root of x is x to the 1/2, which is 1/2 x to the negative 1/2, which is 1 over times. So it's 1 over 2 root x over root x. All right, looks like that. Now, I don't like having this, right? So I can move. So my answer is going to be cosine of natural log of root x. Now, this just gets moved to the bottom, right? Because I multiply it by, well, what's root x times root x? Just x. And the 2's are down there. So it's over 2x. And there is our answer. All right. All right. So here we have arc cosine of 16x cubed. Arc cosine, that's inverse cosine, which is right here. So it's negative du. So it's going to be negative, what's the derivative of 16x cubed? It's 48x squared over the square root of 1 minus u squared. So 16 squared is 256. X to the 6th. Just square that, and there is your answer. That's all you have to do. All right. Now for this one, we have tangent, then we have the inverse secant in the inside. So you first do tangent, which is secant squared. So it's secant squared. Take the derivative of the outside, keep the inside the same. Now I have to take the derivative of this. In order to do that, I look right here. It is. It's du. The derivative is 4x. The derivative of 4x is 4 over the absolute value of 4x square root of u squared, which is 16x squared minus 1. All right, and you can just leave it like that. All right, all of this would be up top. This is on the bottom. All right. All right, e raised to an exponent. So e raised to an exponent is e to the u du, which means I'm going to rewrite everything. E to the arc tan 3x. Now I need to find the derivative, because it's then du, the derivative of arc tan 3x, which is arc tan, you go over here, which is du over 1 plus u squared. So du, which is the derivative of 3x is 3, over 1 plus u squared, 3x squared. 3x, that one is 9x squared. And there's your answer. Just leave it like that. All right. All right, G here. All right, we have the product rule. That's our first, that's our second. All right, so to get the derivative of, remember the product rule is the first times the derivative of the second. All right, now to get the derivative of 4 natural log of x, you have a constant raised to a variable. So it's this right here, a to the u natural log of a du. Okay, so it's 4 ln x times natural log of a, the base is 4, times the derivative of the exponent, the derivative of natural log of x is 1 over x, plus the second, hold on a second, which is 4, natural log is in the exponent, wasn't clear, times the derivative of the first, which is 3x squared. If you kept it like that, that's fine. You could just make this look a little nicer, put this all over x, then plus put the 3x squared in front of there, but all good. All right, last one. We have a natural log within a cosecant trig inside. So natural log is du over u. So it's the derivative of cosecant 4x. Well, to get the derivative of cosecant, we look here. It's negative cosecant, keep the inside the same, cotangent, keep the inside the same, over the inside, because that's over u, cosecant 4x, cancel, cancel, and the answer is negative cotangent 4x. All right, so that does the derivatives. All right, so make sure you know to do ones that are very similar to this that you'll see on the quiz, and then it takes us to our integrals. Okay, now make sure you show all the u and the du or the u squared, a squared. Okay, now remember, you can make u if it's inside a radical, inside a quantity squared. If we have trig, remember all trig rules. If we have x in the exponent, we make u the exponent. If we have what we just learned recently is all of this stuff. All right, now where you have like du up top, and then you just got one, like this thing right here. So a lot of different stuff that we have to be aware of. Okay, one thing I would call your attention right away is ones like A and E. They look very, very similar. All right, e to the 5x over 2 plus e to the 10x, e to the 5x over 1 plus e to the 5x. The difference is, notice, these exponents are different. This is twice as big as that. All right, here they're the same. One of these is going to be u squared a squared. One of them is just going to be a u where you make u the denominator. Remember, you can be the denominator. It's going to be du over u. All right, so, all right, if they are different, like this is where you're going to do u squared and a squared. Okay, u squared, remember, is always the one that has the exponents. That's going to be our e to the 10x. Our a squared is our constant. All right, our u, take the square root of e to the 10x, is e to the 5x. The square root of 2 is the square root of 2. And then the du, the derivative of e to the 5x, the derivative of e is e to the u du, so it's e to the 5x times 5. Throw a dx out there. Now, which one of these ones does this look like? Well, it looks like this one right here. All right, so let's make it look like that. So I need all of du in there, right? Du's got to be my top thing. I have e to the 5x. I'm missing a 5 up here, which means I'm going to put a 1/5 on the outside. So now I have, that's du. Well, what's 2? 2 is my a squared. E to the 10x is my u squared. So I now have this, and I just follow directions. It's 1/5 times 1 over a. A is the square root of 2. Inverse tan of u over a, so e to the 5x over a, which is square root of 2. Don't worry about rationalizing. Plus c, and there's your answer. You can combine these to be 1 over 5 root 2, but if you got this far, you were good. All right. Now, I'm just going to do e just to show you the difference of how this would be done. So this one, we're not going to do u squared a squared. When they're the same like this, we're just going to do u. And we're going to make u the denominator, which is 1 plus e to the 5x. All right. The derivative, all right, the derivative of this, all right, is e to the 5x is e to the 5x times 5 dx. All right. So what am I missing here? I am missing a 5. So I get 1/5. What's on top now? Du over u, which the integral of du over u is natural log of u plus c. So it's 1/5 natural log of u, which is 1 plus 5. Sorry, that's wrong. 1 plus e to the 5x plus c. And there's your answer right here. All right. All right. Now, I'm going to lose this for a sec. So make sure that there definitely be 2 like on there. You have to recognize the difference here. All right. Different like this, double it, u squared, a squared. They're the same. It's going to be u. It's going to end up u and du. It's going to end up being du over u. All right. Let me zoom in on this a little bit. You're going to lose the work there, but it's fine. All right. So let's do B. All right. Classic just trig problem. All right. One trig function, you make u whatever comes directly after it, which is 3x. The derivative of 3x is 3 dx. We need to have all of du, so we need to add a 3. So there's my du. I get 1/3 on the outside. Integral of tangent, which is tangent 3x, which is tangent u du. I then move over to my formula sheet and see that the integral of tangent u du is negative natural log cosine u. U is 3x plus c. All right, and there is my answer. All right. This one here, what are we going to make u? We have, well, u can be the exponent. All right, let's make u negative 2x. The derivative of negative 2x is negative 2 dx. So I need to add a -2 in here. That's going to be my du. Switch up colors a little bit here. So I have -1/2 integral of 6 to the u du. Well, that's a to the u du, which is going to give me, oops, I forgot to make it a negative. -1/2 times a to the u, so a to the u, which is 6 to the -2x over the natural log of a, which is 6. All right. So -6 to the -2x over 2 natural log of 6. All right. And there you go. Box. All right. Scrolling over. Okay. So for this one, I have 2 trig functions. I got a cosecant and cotangent, but they're raised to the same power. So I take whatever is after them as my u. So my u would be e to the 4x. I then take the derivative of that. All right, how do I take the derivative e to the 4x? Well, the derivative's right here, e to the u du. So it's e to the 4x times the derivative of u, which is 4. All right, so I need all of du. So there's e to the 4x, there's my dx. I'm missing a 4. So all the things circled there in blue is my du. Since I added a 4, I got to put a 1/4 on the outside. Integral of cosecant u, cotangent u du. To get that integral, you just look at your formula sheet, which is right here. All right, so it's -1/4 cosecant of u, which is e to the 4x plus c. All right, and there's my answer for D. All right, let's see here. All right, E we already did. Okay, now here we have secant and then the natural log of 2x on the inside all over x. So we have 2 possibilities here. You can make it the denominator. Remember, you could be the denominator, or you can be whatever comes after the trig function. If I just took the derivative of x is just 1. It doesn't get rid of anything up here. So let's pick what comes after it, which is the natural log of 2x. So u is the natural log of 2x. The derivative of a natural log is du over u. The derivative of 2x is 2 over 2x. So you end up with 1 over x dx. That's my du. All right. So there's my 1 over x, right? Here's my 1 over x. And there's my dx. So I don't have to add anything. There's my du. So what am I left with? I'm left with secant. Natural log of 2x is my u. I'm left with secant u du, which is right here. The natural log of secant u, which is natural log 2x, plus tangent of u, which is tangent natural log of 2x, and the absolute value, plus c. There's your answer. All right. Now, looking at G, okay? Actually, G and H both right here, okay? What's different about, actually, I should have put that there, yeah. What's different about G is we have a square root on the bottom, we have a square root with a square inside. You see that, you right away should be thinking about one of these. And the fact that you have this variable here, it looks like this. This should be a u squared and a squared. There's no x on top. All right, so we talked before. If there's just a number up here, you're good. All right, that's to use one of these things here. So we are going to use, let me change colors. We are going to use u squared and a squared. U squared is going to be our 9x squared. Our a squared is going to be 7. So we take the square root to get our u and a. So that's going to be 3x, and our a would be the square root of 7. Our du then is going to be 3 dx. Look, boom, that's all there. My du is there. So let's make it look like this. All right. So I have the integral. There's my du. Good there. I need to have u. X. So I have a 3. So what do I have to do? I have to add a 3 to the bottom, which is a 1/3, because I need this to be u, right? But since I added a 3 to the bottom, a 1/3, I got to take the reciprocal of that. I got to put a 3 on the outside over u squared, which is 9x squared, minus 7, which is a squared. And now I made it look just like this. All right, change color one more time. Now I just follow the recipe. 3 times 1 over a, so it'd be 3 times 1 over a, which is the square root of 7. 3 times 1 over root 7 is just 3 over root 7, just combine that. Secant, inverse secant of u, which is 3x over a, which is the square root of 7, plus c. And there is my answer. All right. So another example here, we have a square root, you have a squared. There's not an x up here. If there's an x up here, then we would do make u this 3 minus 16x squared. But we're going to do, this is another example of u squared and a squared. All right, and that's going to be this guy right here. Notice there's no variable on the outside. So our u squared is 16x squared. The u squared is always the one with the variable. A squared is your constant. All right, the square root of 16x squared is 4x. The derivative of that would be 4dx. The square root of 3 is the square root of 3. So that's what our a is. All right. Now, I need to have, so we're making it look like this guy. I need du on top. I have 1 dx. I want a 4 dx, which means I'll put a 1/4 on the outside. The integral, so now we're good with our du. The square root of 3, which is our a squared, minus 16 squared, which is my u squared. And now I have this, the inverse sine one. So now we just follow the recipe. 1/4 inverse sine of u over a. U is 4x over a, which is the square root of 3, plus c. All right. All right, a couple more left. So it's all about just being able to recognize if we're using u and du or u squared, a squared. We're only doing u squared, a squared for the ones that have like, a square root on the bottom with an x squared inside, all right, and just a no variable up top, or one that has 2 squares on the bottom, just one fraction like this, all right, where you cannot make a u and a du, all right. That's 2 here. Okay. Now, this one here, there's this thing where you have 16, you have the squares in the bottom, but see how there's a variable up top? This is not going to, even though as much as it looks like this, it's not going to be that, okay? We are going to make u just the denominator in this case because there's a variable up top. So it's 16 plus 5x squared. The derivative of 16 plus 5x squared is 10x dx. So I'm going to add a 10 up top, which means I put a 1/10 on the outside, which means what do I have up top now? 10x dx, well, that's my du, over this, which is my u. So I get a nice little du over u, which is natural log. So it's 1/10 natural log of u, which is 16 plus 5x squared plus c. Okay, so because there was that variable up top, this turns into a du over u. It's not one of the inverse trig ones. All right, last one. All right, we have 4x cubed times e to the 16x to the 4th. E to the u, we take u as the exponent. So it's 16x to the 4th. All right, du, the derivative of 16x to the 4th is 64 x cubed dx. All right. Now, I have 4x cubed dx. What am I missing? What do I have to multiply 4 by to get 64? I got to multiply it by 16. So I get a 1/16. That all of this and this is my du, and I'm left with e to the u du, which equals 1/16. Now follow the recipe. What's e to the u du? It's right up here, e to the u plus c. 1/16 e to the u, which is 16 x to the 4th plus c. And there we go. There's a final answer. All right. So I think those are it. Yep. All right. So make sure you know how to do the ones on here. All right. It's a little hodgepodge of all the types of um, integrals that we've done and derivatives that we've done throughout, mostly this chapter, but a lot of stuff that we've done throughout the year. All right. So it's a good last assessment. If you can do all the ones on here, you're going to be fine for the quiz. All right. If you have any questions, please reach out. All right. Hope all is well. Talk to you guys later.